we need to find current I in this circuit. So when we look here, we can see that there is a pi arrangement of resistances, three resistances, and if we want to find the equivalent resistance as seen from here, we need to convert this pi into pi or delta into y. So that's what we will do. So this is there, remaining part stay the same, 240 volts, and 24 and 10 ohms, these two stay as they are, 24 ohms, 10 ohms, and then these three, what will happen is we will have a resistance here in our Y arrangement, and here we will have three resistances like that. So this is one node, this is another node, and this is another node. So the value of this resistance, if I say this one, will be of course sum of the three delta resistances, that is 30 plus 50 plus 20 in the denominator, and on the numerator will be, in the numerator will be 30 times 20, because these two delta resistances are connected to this node where the Y resistance is connected. So 30 times 20. So that gives us, this is 100 and then this is 600, so 6. So our this one will have 6 ohms. Now we want to find this resistance, let's say that one. So in the denominator we will have this sum again, so that's 100, and the two resistances that are connected here in the delta arrangement to this node, the two resistances that are connected to this node are 20 and 50. So 20 times 50, so we get 10. This resistance is 10 ohms. Finally this resistance, and here in this resistance is connected to this node where in the delta arrangement these two resistances are connected, so that will be again in the denominator will be 100 and numerator will be 30 times 50, so 100 because sum of the three delta resistances, and 30 the numerator will be 30 times 50, that will be 1500, so basically this will be 15. So this is our circuit, 15 ohms volts there, 240 volts. So now what we have these two resistances in series and these two resistances in series, and then they are coming in parallel. So we will just draw that. This is a series equivalent one resistance, and then we have 15 ohms there. So that's 15 ohms, and these two when added, 24 plus 6 becomes 30 ohms, and 10 plus 10, 20 ohms. So these two are in parallel. The equivalent resistance will be 30 times 20 divided by 30 plus 20, as we saw the parallel combination. So this will be, so we get 12 there. This is 13 ohms. So if I redraw it, I didn't put 240 volts there, maybe I will put as well. So this is 240 volts, that's 13 ohms, and the parallel combination gives us 12 ohms, and finally we have 15 ohms. So now we have three resistances in series. So our I will be 240 divided by sum of the three resistances, 12 plus 15, which will be 240 over 40, so that will be 6 amps. So that will be the current. So this problem is an example where we needed to convert delta combination into Y in order to solve the problem. So this was our delta. We could have as well converted this delta into Y. If we did that, this is one resistance, one Y resistance, so maybe I will use a different color, I don't know, maybe red. So if we did that, this would be the Y here, this would be Y resistance, this would be Y resistance of course, and this resistance, this would be the 3 delta. So we would have um, something like this. If we did that, this one and then this one and then this one, and finally these two would come in parallel. So these two come in like that. So these two resistances, sorry, so 30 and 50, these would remain the same, 30 ohms, 50 ohms, and that those other three resistance, the delta combination would be converted into Y combination. So we would essentially, of course, get the same current, but yeah, so we can do we can convert either of the delta into pi, delta into Y to solve the problem.